our first example, it's not going to have any vertical asymptotes, so no permissible values. Because if we look at our denominator, if we're trying to find the vertical asymptotes, we're going to try and factor the denominator. So if I looked at negative x squared minus 1, if I tried to make this equal to 0 to solve for x, which is what we were doing yesterday, I would add 1 to both sides, or I could factor it, but let's add 1. So if I square root this, that's right, you can't square root the negative, so there's actually no x values. So we're going to graph this original graph, and then I'll show you how we get the reciprocal function from that. So we still have a horizontal asymptote, as always. So the horizontal asymptote is going to be the same as yesterday's at y equals 0. The original graph, so this graph here is negative. So that negative tells me it's going to open down. We can find our vertex, and our vertex is going to be 0, negative 1. So this graph originally opens down like this. So let me take 2 points here. I'm going to take this point and this point. So we would have, so I'm going to use negative 1 and 2. And the reciprocal function would become negative 1 and 1 over 2. So you're doing the reciprocal of your y value. So that's that point. So it would come up to here. The other point I'm going to choose is positive 1 and negative 2. Sorry. And it's going to become negative 1 over 2. So that one will look like here. And then if I chose another point, like this one, which is 2 and negative 4, that would become 2 and negative 1 over 4. So it's going to get closer to that line. And then I could do the same symmetric over here. Negative 2 and negative 4 would become negative 2 and negative 1 over 4. So it's going to get closer. So the shape of this graph will look something like this as our reciprocal function. Okay, so the next one, we're going to have one vertical asymptote. So that means we'll have one x-intercept. So if you're looking at the denominator of our reciprocal function, so our vertical asymptote, looking at the bottom, is x equaling to 1. So you can see that x cannot equal 1 in the denominator because that would make it 0. And you can never divide by 0. So we're going to put a line at x equaling to 1. That dotted line there for our vertical asymptote. And we always have the horizontal asymptote at y equals 0 as well. Make that y equals 0 here. So now we're going to graph the original, and the original one is what is in our denominator, so the 3x minus 1 squared. So the vertex of this graph is positive 1 and 0. So it's like adding 1 there, or 0. So vertex is 1 and 0 right here, which makes sense because it's our x-intercept, right? So that's where our vertex is landing. Now to graph the rest, maybe I'll find my y-intercept to graph the rest of this graph because I want to know how wide this will open, because the 3 is making it open a certain width, right? So let's put 0 in for x to find our y-intercept. This will give me my y-intercept to be 3. So then we can plot 3 on the y. And then we can just put it symmetric on the other side. So my original graph is going to look like this when you open up. Graph will look like this. So again, it's getting close to those asymptotes, but never touching them. That's not close enough. I'll just go like this. Oops. I'll get it, I swear. So remember yesterday the linear graphs were in opposite quadrants? If you have this parabola that has the one vertical asymptote, they're going to be in quadrants beside each other, like that. Last one is going to have two vertical asymptotes. So looking into our denominator, our vertical asymptotes, 2 and negative dotted lines on 2 and negative 2. And then our horizontal asymptote is always at y equals 0. We're going to graph the original. So my original is the x minus 2, x plus 2. So we can see that my original graph will have those as my intercepts. And then we can find the vertex. You could either add your x values together to find that axis of symmetry and then find what the y value is. So if we added our x values together, this will give me my axis of symmetry. You would get it on 0. So my vertex is going to lie somewhere on the y-intercept because x will be 0 as part of my vertex. So if I put that back into y or into x, it will give me what my y is for my vertex. So I'm putting 0 in for x. Negative 2, 2, negative 4. So this tells me my vertex is at 0 and negative 4. Right there. Now we have the original to look like this. Okay, so to graph the reciprocal function of this, so the reciprocal of 0 and negative 4 is 0 and negative 1 over 4. So our vertex is going to come up to here. So that means that my reciprocal function, each one of these points is going to move up to here somehow. It's going to look like this in that part of the graph. So it's not going to touch any of those asymptotes. So then the other two parts will be here and here. And that's what your reciprocal function looks like for something that has two of those vertical asymptotes and the parabola opens up. So the last example 4, they give you our graph now and they just want us to graph the original graph, quadratic graph from the reciprocal function here. So this is one of our first ones that we did for example 4a. This only has one vertical asymptote. And that's because we just have the one dotted line here. Okay? And it looks like the boomerangs, which I like to call them, are side by side. So this is very similar to this example 2 that I did, where I only had the one vertical asymptote, one x-intercept. So that probably means that this graph is going to look something like this in some way. My original. So the purple is my original. And that's all they're wanting you to do. Just draw the original. And the other one, we've got two vertical asymptotes. So that means I'm going to have two x-intercepts here. So two vertical asymptotes means that I'll have two x-intercepts on my original graph. Now this here is probably the reciprocal of what used to be my parabola up here. So this graph probably opens down like this. And you can also tell it opens down because of the two quadrants in the bottom. Having those kind of graphs in those quadrants tells me that my parabola is going to come down in that original spot. So that should be 0 and 2.
And how do you know it opens down again?
The bottom quadrants have those two graphs in them. So do you see these graphs here and here? That tells me that my quadratic original parabola would be opening in those spots. So page 680. I'm going to start with 3.